3D printed implants are still a niche topic in India, but they are becoming more and more widely acceptable. The limiting point is the awareness among doctors for their use. And even if they're aware, they do not know that it is available in India and can be made locally with a very short turnover time.
So when it comes to 3D printed component, the quality is influenced by three parameters. One is the material we used, the way we manufactured, and the post-processing we do. Before we go for an actual print, so we can validate the design, the material selection for the process, how well we can get it manufactured without any manufacturing risk, also durability of the implant.
The 3D printed implants are relatively new, and secondly, all the implants have to be analyzed independently, individually. So because of that, the mechanical analysis may not be as detailed as the standard mass-produced implants. The second issue is that the mechanical properties have to be validated in the real life scenario, that is in the body. So a good knowledge of the biomechanical properties of the bones and the individual joints of the body are essential, plus long-term analysis of the implants durability in the body by clinical studies are also essential for the mechanical analysis of the implant. Another way to partially bridge this gap is to do a detailed digital analysis. So a lot of softwares that are available which will help in replicating the biomechanical properties of the implant within the body and of the surrounding tissues, the muscles, the bones, which will help in better analyzing the structural properties of the implant and how it is able to withstand the normal loads in the body and the normal wear and tear of daily activities. So there are a few situations where the use of 3D printed implants has a very, very strong advantage. The first and foremost is in problems which are not amenable to treatment by the standard techniques, like complex bone defects, large deformities, or problems in locations which have a complex 3D anatomy, like the pelvic bone and acetabular fractures. The mass-produced standard implants have a fixed size or a fixed series of sizes. The 3D printing ensures that you have a customized implant for every single person. You can customize the shape, the size, the density, the porosity, and even the surface properties for the maximum highest possible function. The surface of the 3D printing implant can be manufactured to suit the biology the best, and this ensures the maximum long-term lifespan of the implant with late failure. For example, if you look at this 3D printed implant, you can see the trabeculae here which are quite visible, which help in reducing the weight of the implant, but also ensure that it can handle the stresses of the body very well. But if you observe it even more closely, the surface property of this has a very fine porosity. So this sort of porosity is not possible with any of the standard mass-produced implants. It's possible only with 3D printing because we have full control over all parameters in the manufacturing process.
Hexagon vision is to create an end-to-end workflow when it comes to 3D printing of implant for a healthcare. Starting from MRI scanning, the part being reconstructed, printing of implant, and making sure that quality of implant is in line with the quality we are expecting. So if I talk about particular solutions starting from CT scanning, so we have volume graphics where we can take the CT scan data, convert it to the 3D model, then we can send it to the 3D printing. So before we go for actual printing, so we can take that model into SimuFact additive, so where we do the process optimization. It is more on which is the best orientation, what are the parameters I should consider when it comes to printing, what is the layer thickness, slicing, hatching pattern should I use. So then optimizing the process in terms of material consumption, support structure, and how many parts should I print. So SimuFact additive gives an overview how best I can manufacture with a given design. So once we have done with manufacturing or we have printed right at first time taking the software suggestion, so then we go for a dimensional accuracy. So we can use our Hexagon scanner. Once we are certified with the dimensional accuracy, then we can go for a quality check. It is more of manufacturing risk. So that can be done with CT scanning, then taken into volume graphics, then analyze like if there is any internal cracks. It might be because of the manufacturing condition. So there might be internal cracks which may not be visible. So we wanted to make sure that part is dimensionally accurate as well as from the quality point of view. So when I say 3D printed implant, so sometimes as it is, it will be more ductile in the nature. So we need some stress relieving or annealing operation. So that makes the 3D printed implant more durable. So all of this can be simulated before we go for actual printing with the help of Hexagon software tools.
Before I came to know that it was manufactured in India, I had inquired from a German and a UK manufacturer. The quotes that I had got were anywhere between 16 to 18 lakhs. But the similar one that is manufactured in India was available for less than 2 lakhs. The other advantage of manufacturing locally is the turnaround time. So the international manufacturers had quoted a turnaround time of 1.5 months at the minimum. And because of the COVID scenario, it could go even higher. But because it is manufactured locally, the entire process, the designing, the manufacturing, the quality control, everything was possible within 3 weeks.
So if you look at the material available for the medical application, so they are quite expensive. Also, they need a special kind of certification and process to be done. So if I take an example of titanium 64 used in aerospace, used in medical industry, which is called titanium ELI. So there is a cost difference in terms of controlling the cost during manufacturing processes. So our Hexagon solution helps our 3D printing service bureau designing their manufacturing process, printing it with the best orientation, best support structure, or also we can help service bureau reducing the powder consumption. So that may result in cost of implant. So at the end we want to reduce the number of trials and error in service bureau, and service bureau should be able to print the part right at first time using our Hexagon solution.
So if the government has clear-cut regulations, then the usage of 3D implants will increase. And the last challenge would be the legal issues. So that is something that is again very difficult to address for a new product or a new technology, and that will have to be addressed simultaneously with the government regulations. The future trends for 3D printed implants are on a strong upslope. It is likely to be very widely used in the near future. As the indications expand and the awareness increases, they're going to be a commonplace and going to be used regularly on a daily basis in hospitals all over the world. 3D printing can be combined with tissue engineering, which allows us to manufacture custom-made organs for individual persons. We have the maximum research going on in 3D printed heart valves and 3D printed pancreas, but it can be expanding to anywhere from facial reconstructions to 3D printed menisci to use in the knee, to various other organs like urinary bladder, which are going to expand the scope of 3D printed implants.